Hi, I'm going to do number 2 now from the review number 1. This is just review number 1. We're going to have several more reviews, I hope. But this is number 2. So let me clear a space here for you. Boom. Yeah. So number 2. Suppose you mix blah 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 with blah blah blah. Oh, there are 2 different chemicals here, and we want the pH. So since there are 2 different chemicals, I know I'm going to need, that's right, a chemical equation. So let me make this nice and big. So hydrobromic acid, that's hydrobromic acid, and potassium hydroxide, that's potassium hydroxide. This is a double displacement reaction, so you make HOH and KBr. Oh, it's already balanced. That was easy. I should probably get one of those Staples buttons where you push the button and it goes, "That was easy." That'd be kind of funny for the videos here. So now we've got the chemical equation. Let me write down the given information. What information have we got here today? 510 milliliters of 0.174 molar. 510 milliliters of 0.174 molar. Wow, that's a lot of dilute stuff. 0.597 molar, 682 milliliters. 682 milliliters, and 0.5 0.517 molar. 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 0.597. 0.597. Molar. Molar. It's a funny word there, right? Molar. Okay, so this was for HBr. This was for KOH. Now let's see how much H. So this releases H plus. That's why it's an acid. This releases OH minus. That's why it's a base. Let's see which one is limiting, meaning let's see which one gets used up and what we have excess of. The excess guy is going to determine the pH, just like for number 1, except it's you'll see here that somebody else wins. And so you'll see what I mean in a moment. Let's get the moles of H plus first, shall we? 510 milliliters, 0.17 molar. So we want moles, so it's 0.174 moles in 1 liter of HBr. This is moles of H plus or HBr, whatever you prefer, because it's there's only one H here. It's H plus concentration is the same as the HBr concentration. And I know that there's 1 times 10 to the power of negative 3 liters in 1 milliliter. And I know I had 510. I had 510 milliliters. So these cancel out except for moles. So the moles of H plus are 510 times 0.174 divided by 1,000. So that's 510 times 0.174 divided by 1,000, and that's 0.0887. 0.0887 moles of H plus. Moles of H plus. Huh. Yeah. Just trying to be neat sometimes, not all the time. All right, so that's it. That's the moles of H plus. So just stick that right in. Okay. Now let's get the moles of OH minus, shall we? So that was, what was it? 0.597 molar and 682 milliliters. So 0.597 moles of OH minus. OH minus. Huh, so neat right there, right? Okay. OH minus, and in 1 liter of the KOH. And in 1 times 10 to the negative 3 liters of KOH, there's 1 milliliter of KOH, and I've got 687 milliliters. Is that right? Yeah, 682 milliliters actually. 682 milliliters. So it's only 1 OH for every KOH. There's no 2 or 3 or 4 there. So that means this is all okay. Very simple here. 682 times 0.597 divided by 1,000. 682 here times 0.597 divided by 1,000. And that's 0.407. 0.407 moles of OH minus. All right, let's insert that right in. 0.407 moles of OH minus. So, who wins? This guy wins. OH minus wins, meaning OH minus is, so OH minus is going to be left over, meaning H plus is the limiting reactant. This is going to get used up, all used up to make water. Remember the equation is H plus OH minus makes H2O. So this is happening. Anytime you have H plus and OH minus, nobody has to tell you that it's happening. It's happening. Like this, like they say, oh, it's on. Yeah. So 0.407 moles minus 0.0887 moles equals, I can only have 3 digits after the dot here, so 0.407 minus 0.0887 equals 0.318. So this is 0.318 moles of what? Who won? OH minus won, because H plus was limiting. So the OH minus is left over. But the question was, what is the pH of this thing? Now, pH deals with concentration, not with moles. So I'm going to have to get the concentration of this. So 0.318 moles of OH minus divided by the total volume, 510 plus 682. Now that I can do in my head. So can you. So let's do it like this, and then put a dot there for the liters instead of milliliters, and that's going to give us 1.192 0.267 molar. That's 0.267 molar. I'm trying to get this to be italics, but oh, because it was italics already. Oh, okay. So yeah, molar OH minus. So now to find the pH, I can just take the negative log of this, right? Wrong. Yeah, I know that you knew. I know you knew. It's all right. I know you knew. So that the POH. So the POH equals the negative log of 0.267, and that is going to be log of the answer. That's going to be 0.573. 0.573. So the pH is 14 minus 0.573, which is going to equal this plus 14, 13.427. 13.427. So do you see how this is a little bit different than number one? 13.427. 13.427. Let's see if we're within the allowable error. Let's see. Oh yeah, look at that. Spot on. Okay, thank you, bye.